Now we're going to begin basic dimension exercise number 5. For this, you're going to need the inspection plate that came with the machine that you bought or the video course that you bought. It looks like this. I will be using a star probe. The machine I'm using is called an Extreme. So set the part on the table so that if you're standing in front of the CMM looking at it, this is the view that you see. You also need the print. Print has multiple datums. There's datum A, B, and C, which we'll be using for our coordinate system. A is the primary datum, the top plane. B is the center hole. That's the 472 hole here in the center. We'll be using that as our origin. And then C is the small hole to the right. So this is a plane, circle, circle coordinate system. We're going to be measuring a plane, setting reference, defining datum A. Then I'm going to measure B, set reference, and define datum B. Then I'm going to measure C, and I'm going to draw a line through B and C. And I'm going to reference off of that line and define that as datum C. There is a problem with this print. As you can see, datum E is the right side of the part. That's this side right here. There's a parallelism called out from this side to datum E. But there's also a true position call out of the side hole here to the top surface A and this back wall E. Aberlink requires a point to be the datum if you're going to position to it. So what I'm going to do is I'm going to not define this plane as datum E, but I'm going to make an intersection point at this quarter and define that point as datum E so that I can do the position note. I designed this so I could show you Cartesian positioning as well as polar. So these holes are going to have polar coordinates, the radial distance and the angle. The radial distance is half the bullhole circle and the angle is given here. So let's get started. First thing we're going to need to do is start a new inspection program. Now I am offline. I'm going to bring in my CAD model. This would be the measure ribbon. The pink background indicates that there is no model and we have not set the visual alignment. So I'm going to import the model. If I click the file, the notebook here, it brings me to a browser and then I browse for my file. It can be either step where I just. The other one here is a pull down, and a little pull down has previously opened models. I'm using the mouse wheel to zoom in and out. If I push the wheel down, I can rotate. If I hold the right button and the wheel down, I can pan it around. So what I'm going to do is I'm going to start by setting the visual alignment. So I'm going to show you, and that's this right here. So if I click this, I have two options. One, I could simply measure where I want the Z to be, the direction of the Y, and then the direction of the X, and then the direction of the Y. And the background goes blue, indicating that I've completed it successfully. I'm going to redo it. So I go back to set visual alignment, clear it. And the reason I'm doing this is I'm going to show you how to do it a different way. I actually prefer this way. So when I hit set visual alignment, this button right here, if I push it, it tells me to place the CAD model so that if I'm looking straight down at it, I would see the X and the Y. If you look down here, you can see the Z is actually, this coordinate system is rotated, so the Z is coming out of the side of the part. So I'm going to use this tool here. I'm going to go to the top view, and as you can see, that's the top view because I'm looking down in the Z. I need to rotate it. So now why did I choose the X-axis? If you look over here, the X is going in the proper direction. I want this direction to be my X-axis, but I want the Z to come perpendicular from the top plane. So if I rotate that, now it brings up this plane here. All I have to do is push this button. As you can see, it's already rotated it, and as soon as I click on the model, it aligns the visual reference. Now the Z is going in the proper direction. If you look at my stylus, I'm going to pull this off. This black solid line is the stem of the ruby. So that's telling you the direction the probe is going. And then the, excuse me, the dashed line that you're seeing is the vector of the surface that you're holding it to. So if I come to the side here, it goes out. Now you can see the dashed line is perpendicular to that plane. So I'm going to do isometric view. And now we're going to get started with inspection note. So from the inspection ribbon, I hit this. Now I've already pre-typed in a note. So you just go to text and then type in a note. I set part table and shown. I'm going to go to the image button and I'm going to browse for that picture that I used earlier. So now I have a setup photo. So this is a note telling the operator how to fixture the part as well as a picture. So now we're going to start with measuring the plane on top. I can select, if you don't see the toolbar in your CAD window, you need to push that little ruler button. So I'm going to pick the plane, but before I do that, look at my stylus. The vector's right, but the stem is not, and that's because, I'm going to cancel this, that's because I don't have the right probe chosen. I want the probe in the Z minus. I almost screwed up there. So now the stylus is pointing down. It's the bottom stylus of the star. It's that one right there. Before I had that one chosen, which is why the stem was off. So you want to make sure you got the right probe before you start measuring your plane. Pick the plane. Notice how I'm getting all the corners, spacing it out to cover as much surface area as possible. I'm also using more than 3 hits. The smiley face here tells me if my form is good. There's a threshold in the settings that you can control. Set reference. I'm going to define it as datum A and say OK. Now I'll display the datum. I'm going to double click on the edge with the left mouse. Right click, datum, do the drop down, select A. I'm actually going to bring it over here. This screen's going to get pretty busy. Next thing I'm going to do is I'm going to measure the inside circle here. There is a one point circle tool, so if I just click in it, it automatically calculates the circle off the model. If I go into CNC, you can see it's going to be 4 points. If I wanted to make that 6, I could also control the depth. I'm going to go 78 thousandths deep, which is 2 millimeters. And I hit make, and as you can see it flash, it just updated it. So every Z hit is going to be taken at the same depth, and it's going to measure 6 points. Click this button to get the screen back. Set reference is going to set our X and our Y origin, and I'm going to define that as datum B. So I'm going to minimize this, and I'm going to define our datum. So I'm going to double click, right click, datum B. I'll put it like just like that so it shows like it is on the print. Now I need to measure the other hole. That's that hole right there. Once again, single point click. I'll set it to 78 thousandths and change that one to 6 points as well. I say make. Turn it back here if you want to see the graphic screen, and then hit finish measurement. So now that I have both my circles measured and the reference set, I'm going to construct my line. I go to line, construct, select the first circle and the second circle. It asks me for a center line through the points. I check the button, hit finish construction, and it brings the window back up. I want this to be datum C, and I do want the reference set so it clocks the part. And if you wanted to, well, actually it's a constructed line, so we'll hit finish here. Okay, so to get the rest of the circles that you see in my print, these here, I'm going to use a feature called the ring array, or feature array. That's over here on the left-hand side. It's under the inspection ribbon. It says features to be copied. Well, this is the one I'm going to copy. And then I hit the next button. It says center feature. This is the center feature of the circles. I'm going to do 6 circles. It's 360 degrees, which means it's going to be every 60 degrees. When I hit OK, it generates the circles. Now this one down here on the print is actually a slot. I'll show it to you on the CAD model. So I'm going to delete that from the program. Very simple. From the View Edit ribbon, I just hit the eraser button. The color tells you it's on. It's also highlighted the background. As I pass over it, it goes gray. I just left click one time. Now I can turn that off. So as you can see, I measured these features here. So I'm going to go ahead and show you how to position these to datums A, B, and C. So we have, these are going to be polar coordinates. This is 60 degrees from our axis, which is 0. So it'll be 0, 60, 120, 180. And then that one will be 300. The bolt hole circle is 945. We're going to need to use the radius of that. The radial distance from the center to the center of each holes is 4725. And it is MMC at 20 thousandths. So let's do, the first circle is our datum B. Sorry, I apologize, datum C. So, and it's positioned with no angle. It's just positioned out to the radial distance of B. So I'm going to go ahead and define this as datum. I'm not actually defining the datum, I'm just showing the label. So now you can see where datum C is the line. So I'm going to double click on the edge of this, right click, position, polar. We'll bring it over here. Now I right click on the leader line. You want to do your geometric work first, otherwise it unchecks boxes on you. So we'll go MMC. This number is 206. Now the reason for that is the nominal size of that hole is 236. The tolerances on the print are plus or minus 30 thousandths. So if I took the 236 and subtracted 30 thousandths, I would get the minimum size of the hole, which is the maximum amount of material in the hole, with it still being in tolerance. So 206, MMC, 20 thousandths. I'm not interested in either the angle or the height. Down here I want to add my datums. We'll add A and we'll add B. See how it changes that? So you want to do all this first. Define your datums first because it changes a lot of these buttons. So Z, it was projected. So the circle was projected up to the plane. I'm not even going to bother reporting it. 4725 is my nominal. Remember, that's half of the 945 bolt hole circle. It's the radial distance. Everything's good here. There's not going to be an identifier. And layer. Right now I've got 2 layers set up. So layer 2, we'll hit apply changes and hit OK. As you can see, obviously there's no measurement. I'm offline, so there's no actual value. But as you can see, it puts the node in, just like it is on the print. We also need to do the diameter. So I'm going to double click. And right above it, I'm going to put the diameter in. I'll right click on that. I don't want to do the geometrics. I don't want an identifier. As soon as I change it, it's going to recheck both of those buttons. Again, and I'm going to continue to do this so that you can see it every time until you remember it. So change your nominal and change your tolerances. Then you can uncheck these and hit apply, and as you can see, it's just showing you the diameter. All right, so now we're going to do the position of these other holes. So I'm going to double click, right click, polar, position polar. I'm going to right click on the leader line. If you want to avoid rechecking these, start with your datums, A, B, and C. Geometric tolerance is 20 thousandths at MMC. All these holes are going to be 206. Every one of these holes is the same size, which is 236. So 206 MMC geometric, that's right. Let's fix these. 4725 and 60 degrees nominal. We'll uncheck and hit apply. Now I still want to take off the label. So as you can see, it's showing me the positions to A, B, and C at maximum material, and it's also giving me the radial distance and the angle, the actual measured values. This makes it easy for the machinist or the engineer to look and see what the deviation was. Right click, start with the datums, 20 thousandths MMC, maximum material condition for that hole is 206. Double check that. I can change your nominals and your nominals. So it's 120 degrees. We'll uncheck that and hit apply. B is still there. Simply uncheck it, re-hit apply. And that one's done. The next one's going to be 180 degrees. Double click with the left mouse, right click, position polar. Then I right click on the leader line and make my changes. So if I were to uncheck this now, as soon as I hit the A to the B, A to datum A, it rechecks it. So that's the reason I keep starting with the datums. .206. Change my nominals. The 180 is there. Uncheck that and hit apply. Forgot to uncheck B again. The last one will be 300. Changing the nominals, 300 degrees. And as soon as I uncheck B, it rechecked the identifier. All right, so as you can see, this screen's already getting kind of cluttered. So I'm going to show you how to set up some layers. So under the View Edit, you'll see 3 pieces of paper. I'm going to click it, and this screen's going to appear. Right now, they have 2 default layers, layer 1 and 2. I'm going to add one. And I'm just going to call it positions and say OK. So as you can see, I've got a new layer. Now if I were to right click on this, I could actually change my layers to positions for each one of these. And what this is going to allow me to do is keep them in the program, but not display them. You don't have to use the labels that they use. Layer 1, layer 2, you can do custom labels if you want. So I'm just right clicking and going into the layer on every one of these and changing it. Now I can turn off the layer. These will still be in my part program, but they're just not going to be displayed on the screen. So I go to the layers and I just uncheck positions, and voila, I'm back to a clean screen. So down here, we're going to look at the next dimensions we're going to do. What I'm going to do is I'm going to go ahead and measure this slot here to show you how to do it. I'm also going to add a dimension that's not on this. I'm going to measure this cone in here, and I'm going to create a plane that's 20 thousandths down from the top plane for a gauge circle inside the cone. I'm going to show you how to do that using an offset plane, just as an added little bonus for watching the exercise. So the next thing I'm going to do is I'm going to measure my slot. So let me minimize this, pull up the CAD model. Now there is no slot tool in this software, so what we have to do is we have to measure a circle, a line, and a line. So I'm going to rotate it, go to circle, get the inside there. I'm going to say okay to that, then I'm going to go to line. Two points is good. Back to circle. If you don't like the ball being displayed, I could simply turn this off. That circle's measured. And now, when I choose my line, it's not showing the ruby. So if the ruby is getting in the way, that's what this button does right here. So once it's turned on, I brought it back. So now if I minimize this, you can see I've got my slot. I'm going to move the B out of this slot. I'll bring C up a little bit. So you can move the datum labels once they're positioned. Just left mouse and drag. So if we look at the print, we've got a 472, which is the overall length of the slot. And then I've got a distance here to this edge. So I still have to measure this datum E side. But right now I can tolerance this 472. Left click, left click. Drop it down. I'm going to right click. As you can see, it's from center to center. Max to max will bring you to the outside edge of the outside edge. Change my tolerance zone to the plus or minus 30 thousandths. I believe it was 472. We're going to check that in a minute. I'm going to turn off the identifier. You can see it puts the little two, looks like upside down V's, letting you know that it's a maximum circle. So double check the print, and I did get the nominal right. So I'm going to have to measure this datum E surface, but I'm not going to define it as datum E. So when I do this parallelism, it's not going to show the datum E. So 787, this will be a minimum distance from this circle to that plane. So what I need to do at this point is I need to measure this plane right here. So I'm going to choose my stylus, and it's going to be the one in the negative X. And all I'm doing is looking for my stem to be perpendicular to the surface. That's telling me that I have the right probe when using a star probe. Plane. Get up in the corners. Hit OK. If I minimize this, you can see the plane's right here. So now for that 787 dimension right here, I'm going to left click one time on the circle, and I'm going to left click one time on the plane, bring it down. I'll right click, (787) plus or minus 30 thousandths. Uncheck the identifier, hit OK, say OK to that. If you wanted to, we could create a layer called linear distances or linears or any of that, and then we could apply the layers to them just like I did before. I just wanted to show you how to do it. I'm not going to do it anymore. So these two dimensions are done. To do this one here, I could actually do the 669 right now because I have both features measured. So let's do the 669. So left click, right click. Sorry, left click. 30 thousandths, 669, uncheck that. There you go. All right, while I've got the, actually I'm gonna go ahead and do this when this view's done. So let's measure the back plane on this wall. I'm also gonna go ahead and measure the two holes on the back side of the part while I'm doing that. So my stylus is going to be pointing towards the front of the table because I'm working on the back. So the stylus I'm gonna choose is this one right here. I just got done using this one, which is pointing in the negative X direction. This one's pointing in the negative Y direction. It's coming towards me. Minimize. Let's bring up our CAD model. So I'm going to rotate it around. So when I choose my stylus, the black stem should be perpendicular to the black of this. The back of it, I apologize. And as you can see, the stem is perpendicular. So pick a plane. I'm going to space the points out. Cover as much surface area as possible. Say OK to that. I'm also going to measure the two circles with the one circle tool. And say OK to that. Now that's actually datum D on our print. The big hole is defined as datum D. So I'm going to go ahead and define that real quick. Do the drop down, say OK. And then down here, if you can see underneath, that's where the circle is. I'll display it in a minute. I'm going to get this one first. Grab that circle. And again, I could go into the, here and set the penetration to an exact amount. Change the number of points, and then hit make to update that circle. So let's minimize it. I'm going to resize this so you can see the bottom view a little bit better. Double click on the edge, right click, datum D. So I'll display it off to the side. So now that I got datum D done, or I got the back wall measured, I can do this 748, which is the distance from the center hole to the plane I just measured. So this plane, left click to this circle, right click, 748 plus or minus 30 thousandths. Uncheck and apply. And I'll move it over to here. So the 748's done, the 669. I need to measure a plane on this side to do that parallelism. And I also need to measure an angle on this to do the angularity as well as the 60 degrees. This overall width of 134 and this, if I can get a plane measured here, then that'll take care of that. So I think what I'm going to do now is get rid of the remaining two dimensions there. I'm going to go ahead and change my view to isometric, and I'm going to measure this front plane. So in order to do that, I have to change my probe again. So now my black solid stem is perpendicular to the surface, which means I have the right probe. Plane. I'm going to say OK to that. Now I can come into here and I can do the distance from one plane to the other for the 134 overall width. There is no GD&T. There's no parallelism on that one, so I'll change my tolerances, uncheck, 134 is good. And then I can also do the 181. Let me show it to you. I just did the 134. The 181 is from the center slot to this edge. Now, I could choose one of these circles and do it, but what I'm going to do is I'm going to show you how to make a midline between these two lines, just because it's a training video. It's not how I would probably do it, but construct, pick the two lines, midline, and as you can see, it creates a dashed line. Now I can do a distance between that line and the front plane for my 181. Right click, there's the 181, and it rechecked the identifier when I changed the nominal. So I got to right click to turn that off and to turn off the GD&T. So the 181, the 134 distances are done. I've already done these down here. I've done this GD&T. I'm not doing the bowl hole circle. I'm going to show you how to construct it real quick, but I'm not going to tolerance the 945. The 60 and the 945 are tied into these positional notes. They're your basic dimensions. You really can't apply a linear tolerance to a basic dimension. Not supposed to anyhow. Everybody does. So the 748, the 669 is done. So I've got these three up here to do. So I'm going to show you how to do that bowl hole circle real quick. So I go to circle, construct, and start choosing my circles. When I get to the second one, PCD means pitch circle diameter in English. We call it a bowl hole circle, so just make sure that's selected. And then when you continue to choose them, as you can see, it draws the circle. Finish construction, and we'll say OK to it. So now I need to measure the angled line. In order to do the angled line, I need to choose the right probe. So I'm going to go negative Z, which is pointing straight down. Just measured a plane there. Selected OK. Now while I'm over here, so I could actually do that 60 degrees and that angularity, but I got to get this plane measured here. I don't want to use this straight down stylus because I've only got so far down before I hit the other star. So I'm going to change probes again. And I believe this will be the positive X direction. Yes, you can see because it's perpendicular. All right, now that plane that I just measured, plane 17, that plane's not showing up here, so I'm going to find out what I did wrong. It's down here, and the reason I know that is that's my first measurement. If I hit one back, that was my last, and it highlights it, so I'm going to delete that. Turn off delete. There's the small plane that I measured with the Z minus. There's the bowl hole circle. So I'm going to remeasure the plane right here. All right, so I've got the right stylus chosen. I'm going to choose plane. It might have feature predicted a line or something last time. I don't know what happened there. So now I can see my plane. All right, so this is defined as datum F. So I'm going to go ahead and define that plane as datum F. And I'm going to do this parallelism between this plane and datum F. Now, since this plane is supposed to be datum E, I'm going to choose it first when I go to do the parallelism. So I'll choose that one, choose this one. I grabbed the wrong feature, not a big deal. That's what undo is for. There's the plane. There's the plane. Right click. Geometric tolerance. I should have checked that. 1,000. And again, the length is the size of this plane. The second one I chose. I'm going to turn off the identifier, and I don't want to see the measured dimension. So when I hit apply, it's just showing me the parallelism. Next thing I can do is I can do the 60-degree angle. So if I click that plane and click this plane, I can get that 60 degrees. It's also going to give me the angularity. So this one right here is 60 degrees and the angularity to datum F. So now, did I choose the order correct? I chose this one first, then that one. But it wouldn't matter because I haven't defined this as datum F yet. So I'm going to undo that dimension, right click, call it datum F. I'm going to double click to display it, right click for datum. So now it's datum F. So now if I left click this one first, then this one, when I bring it up, it already pulls the datum label in. Now I can right click, put the tolerance zone in, datum F is there, uncheck the identifier, we'll do, that's going to recheck here in a second. Plus or minus 1 degree is the linear or the angular tolerance for the 60 degrees. Hit there, say OK, and that note's done. So both of these are done. I didn't put the tolerance in right. I put 10 thousandths instead of 20. Easy change. I'm going to fix it real quick. So here's your parallelism, and there's your angularity. All the dimensions are done except this perpendicularity. I'm going to do that in a second. So first of all, let's change our tolerance on the angularity. So I just right click and go in and change it. So to do a perpendicularity of the center bore, it has to be measured as the cylinder. So let's go ahead, we're going to pull it up. I'm going to use a cylinder tool. If I click above and then go right below it, it predicts the cylinder for me. So I'm going to go ahead and say OK to that. And now if I minimize this, as you can see down here, I have a cylinder. So if I choose the plane, then the cylinder, and it's going to ask me, because there's two features there, the first circle and the cylinder. I'm going to choose the cylinder. It gives me the perpendicularity. I could bring it down here. Let's look at our print and see what the tolerance was. 1,000ths to datum A. So right click, we'll change that to 1,000ths. The length is the depth of our cylinder that I just measured. We're not going to report the 90 degrees or the identifier. We're just going to show the perpendicularity. And then to do the diameter, I simply double click on the edge. I'll do the circle for the diameter. When I click on it again the second time is when I get the box. I'm going to do that again because that's a little bit tricky. When I double click on it, I get an option for which feature. So I pick 2. I have to click on it again and pick 2 to get the box. That's only in the case where there is 2 features sitting on top of one another. So we'll put in our tolerances. Oh, might as well. No, it's going to change as soon as I change my nominal, but that's fine. And there's your diameter, 472. You could bring it up here, bring that up there if you wanted to, so it's right underneath, which is how the print looks. So there's those. I'm going to go ahead and measure that cone. So to measure that cone, and this is not on the print, I just want to show you how to do it. It's a common question. I need to change my stylus so I'm perpendicular to this surface. The dashed line is the direction that, of the vector. It's not the stem. Negative Z. Now I can measure the cone. So I'll pick a cone. Just telling it where I want the hits taken. I'll go down in deep. This would be where you'd want to turn off the right here so the points aren't showing up. But I got the cone. I could go into CNC if I wanted to and make the depths consistent. The angle, the included angle, number of points that are being measured. So if I wanted to change this to, let's say, 50 thousandths and 120, and then remake it, it'll update them. Go ahead and finish that. Now the reason I did this was a lot of customers have a diameter of the cone at a depth from the plane, at a certain depth. So to do that, I'm going to zoom in on the bottom one down here. All right, so I'm going to give you a diameter 20 thousandths down from the top plane, which is right here. So if I just go to plane and construct, I can double click that plane and it's going to give me, and I picked the wrong plane, so I'm going to stop and do a different plane. We'll space out here a little bit. We'll say construct, and it did not do it because I got to reopen the feature. Construct, double click the plane, and it's asking me for an offset amount. I'm going to do minus whatever the gauge depth is, and that just created that plane. It's the highlighted feature right there. So if you wanted to see which one it was, just use the arrow back button and it shows it to me. And apparently I didn't get deep enough with it. But now what I could do is that cone doesn't go all the way up and intersect with the top plane. So there's my plane. So I'm going to make a circle between the two between that feature and the cone. Circle, construct, pick my plane, pick my cone. It comes up with a message giving you the basically what it is there's an axis coming out of the cone and it's letting you know that it's 90 degrees, and then there's a vector coming off of the plane that's perpendicular, and it's just telling you what they are. Most of the time it's something different, like 89.999. It's just letting you know they're not exactly perfectly perpendicular. However, in this case they were, because it came off of a CAD model. So there's your diameter. You can see it's showing it up here. So if I hit OK, I could double click and tolerance the diameter. And that is the diameter that we constructed 20 thousandths deep off of datum A. So I don't really need any of those features. I just wanted to show it to you, so I'm deleting all three of them. Back to the print. All right, that's everything on this drawing. So let's do this one up here. The profile is going to be done in a different video. It's called CAD comparison. If you do not have the CAD comparison module, you cannot do it off of the CAD model. It is possible to do it with a DXF. So what I'm going to do is, I've already defined this as datum D. I'm going to go ahead and do the diameters and the concentricities real quick. Let me minimize this. So we're going to start with the small hole to datum D, concentricity, and I'll do the diameter. So to do that, I'm going to pick the diameter, then the small hole. As you can see, the concentricity comes up. right click, enter the tolerance zone, which I didn't even bother to look at. So it's 1/1000ths on both of these. Okay. Tolerance zone, no identifier. So there's your concentricity. If you wanted to go in and tell it, put datum D in the call out. That's how you would do it. Now I'm going to do the diameter of the small hole. Double click. Right above it, left click. 354 was the size of it, plus or minus 30/1000ths. Geometric. It's not even calling out geometric on that diameter, so we'll just do that one. Now the other one, it was a roundness of 1/1000ths. So if I look at the print, I'm talking about this dimension right here, the diameter of the big hole, 787. So I'll right click, make it 787, plus or minus 30/1000ths for the diameter size, 1/1000ths for the run or for the circularity, and we'll uncheck that and hit apply. So now that one looks just like that one. Datum D, can't do that one. All right, I'm going to do the one to the edge, but I am not going to attempt to measure underneath the part because I'm offline. So I'm going to skip the 472. So to do this hole to the edge, I simply just click the plane on the edge and click the center hole. We'll give it plus or minus 30/1000ths. Turn off the identifier. So there's your 472. All right, so now if we go down here, next thing I'm going to do is I'm going to make the intersection point for this positional call out. I still have to measure the hole inside here, I believe. I need to double check. I have the hole on the other side right here, but I don't believe I've measured it. I know I got the plane, so I'm going to change my probe and get this hole measured. I'm just going to use the direction down here. It's going to be positive Y direction. So if I move the probe back over top of it, I can see it's there. There's your circle. Again, I could go into the CNC details, make it 6 points, control the depth. Hit OK. Now I want to make an intersection point right there and define it as datum E. It's just the way the software works. It's actually the same way in SEMA Manager. If I was going to do a datum feature other than the coordinate system, I would have to define that corner point. So first thing we're going to need to do is make a line between the two planes. I'm going to show the isometric view so you can see. Well, that doesn't do a very good job showing you anything. It's kind of crowded. We'll do a redraw. Right click, redraw. So line, construct. I'm going to pick my top plane and I'm going to pick my side plane. And it made a line right on top of that plane. So then what I'm going to do is I'm going to intersect the front plane, which is that one there, with the line, and it should give me the option to choose the line. It did. All right, now because I made a mistake here, I didn't ask for a point. So I got to go to point, construct. Now I'll choose the plane, and when I choose the line, so it's going to show me that little pink point, which I'm going to call datum E. So now when I go to do the position, again, the two circles are sitting on top of one another, so when I click on it, it's going to ask me for which one. Circle 24, click it again. Let's try that, click it again. Now I get the box. Right click, position Cartesian. We'll put it right there. I will right click on this, add datum A and datum E. And as you can see, it updates the nominals. Watch that. See how it's 0.2 and 5.9? Right now it's calling it back to my 0, which is right here. Datum A, nothing really changed. But when I choose datum E, now everything goes to it. So my nominals are 472 and 472 off of the print. Let's look at the feature control frame. 20 thousandths at MMC. So we'll do 20 thousandths MMC. We need to know the size of the hole. Should have been 354. It is. So if I take away 30 thousandths from 354, 324. Turn that off. Well, it's going to recheck as soon as I hit that button. There you go. That's good. We don't care about the Y. We're only looking at the Y is because it was projected onto a plane. That should be it. Turn off the identifier for the 5th time. We'll hit OK. So now that is showing you these basics, the 472, as well as this note here. However, I still need to do the diameter. So we'll click one time, pick circle 24, click it again, circle 24, right click. And there's your diameter. Now there's a couple reference dimensions I did on here. Technically you're not supposed to check these, but everybody does. So I'm just going to go ahead and do it. And all it is an angle between the plane on the right side, this one here, and the top plane. So we'll pick the first plane and then click on here and the second plane. And there's your 90 degrees. Right click, plus or minus 1 degree. 90's there. We'll uncheck the geometric and uncheck the identifier. All right, so now what I need to do is I need to measure this inside here. So I got to measure a plane. To get the center point, the way I would do it would be to measure a cylinder inside there, but it's not very deep, so it's going to be tricky. But if you measured a cylinder, the axis of the cylinder would intersect with that plane, and then I could do a distance between that point where they intersected and the top plane for this 276. This one's simple. It's just the center of the circle to the edge. So let's go back to our CAD. I need to change my probe again. I want to go straight down with this one. And because I am using a fixed head, I cannot rotate it. I'm limited as to what I can do, so I'm going to measure a plane right here. Actually, I'm going to come back up top. I don't want my star to hit this wall. So I'll say OK to that. I'm going to zoom in and move it around a little bit, rotate it down. I'm going to go to cylinder. And this is a case where you want to turn this off. This is a goofy cylinder the way I'm doing it. I should have done circle, circles, point, 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 and then drop down and did point, point, point. So I'm actually going to redo it. So I'll do a point right there, point right there, and a point right there, and then I'll go in a little bit. And we'll say OK, and let's see what it looks like. Yep, there's the cylinder. So now, and I could have just did a circle with projection on, but I wanted to show you how to intersect. So we're going to make a point between the plane and the cylinder, and you'll see the intersection point right there. So now if I chose that point, point 29, and the top plane, that is the 276 dimension. Double click the edge of it, we'll do the diameter. Right click on the leader line. I believe it was 630, yeah. 630 plus or minus 30 thousandths. Turn off the GD&T in there. So there's your diameter, and we could display it down here. It checked the GD&T button again. And then the 394 was this edge here. I'll show it to you. The 394 dimension right here is the center of the, is actually, I could use either the cylinder or the point. It'd be the same thing, but this wall, this plane datum F to the center here. It's a linear dimension. I'll actually use the point. And we'll right click. All right, now we did the diameter, we did these distances, the 90 degrees, everything on this view is done. So we're done with this entire section. We just got this down here to do. So I already have for the 45 degrees, I already have both these planes measured. So I could do that one real quick. So that was the angled plane here to the front plane here. And it got the back plane. You can see where it highlighted. So I'm just going to left click and say undo and try it again. I'll go that plane to that plane. There's the 45. So we'll bring it up here, left click. We're just doing the plus or minus 1 degree. No GD&T, no identifier. And if you want, you might be able to bring that down here. And it's not going to look that good down there. But notice when I clicked on it again, it rechecked that. That's odd. So 45's done. Flatness is very simple. I didn't do the flatness on the other one. I'll do them both real quick. So I've got a flatness on datum A, and then I've got a flatness on the front view. We'll do those two real quick. So the top plane, I'm just going to double click with the left mouse, and then left click. There's your flatness. 1000s, turn off that, hit OK. We could even bring that down here and put it off to the side. And then the other one is the front plane, so I'll double click on the edge, bring that one down, left click. Back to the print. 659 is an intersection. I have to make a point right there. So I've got a plane measured there and a plane measured there. So if I turn those, if I constructed a line where they intersect, I could then, that would be running this way. So I'll intersect the plane, datum F here, and the plane I measured here to create this line you see right here. And then I'm going to intersect it with datum A, the top plane, to make that point. And then I just simply do a distance between that point to the back plane. So right now what I need to do is I need to create an intersection line. So line, construct this plane and that plane. I apologize, I just did the wrong planes. Try it again. Line, construct. Actually, no, I didn't do the wrong planes. These two planes. Say OK. And now I can't see the line. That's what this comes in for. The arrow is over here. Go to the last one, or you could do the drop down and pick that line. I can see the lines right there. So if I were to go to point, construct, I can left click because that line was already highlighted in orange. So anywhere I left click, it selects it. So it's put right there. Then I'll pick the plane, and you can see it makes the point right where I wanted it. Now, what was my nominal? 659. Simply left click, get 0.31, and then pick the plane. And then that was supposed to be 659. Right click. Something's going on. Shouldn't have been that high of a number. Get rid of the dimension. Let's see, so the intersection point, let me look at the drawing again. So if I was looking at the front view, no, it's right. It must just be my nominals in my CAD model. So I'll pick the point again, pick the back, bring it off to the side. 30 thousandths. Uncheck that. $90 degrees. I don't have a plane measured on that surface. I've already shown you how to do the 90-degree angle several times. And the surface I'm talking about, it's looking for an angle between this face, which I've already measured, but this plane right here. This plane is really kind of small and hard to get to with the stylus I have. We already did the flatnesses. So that's everything on the print. It looks like it's pretty much done. So if you haven't already saved your program, you want to do a save as. And if you want to do the, actually I'll just call it number 5 here. If you want to, you should have done the printer. So let's do a run report and then we'll resave it. So I've got the name changed. Enter your information. 1, 2, 3, 4. Drawing number 1. We'll throw a customer in there. Serial number 1, 2, 3. Material, I could reference aluminum or aluminum. Inspector bill. Throw a little note in there for you. Hello Kitty. So now I'm going to do the tabulated dimensions. This is what it's going to show, the identifier. I'm going to turn that off. I really don't want the identifier. It's mainly because I didn't choose it. So the nominal, actual, error, all that stuff. If I want to view the report, I can hit it right here. So there's my report. The failures are because I'm offline and I didn't measure anything, but as you can see, it populated this up here. And then I could send it to the printer. However, I'm going to say OK to that and then hit save. It should save the report. Now, to run the program, if you're offline, we did a save as. So what you would do is you would go to the online software on the CMM, open up the program, and go here to your Open Inspection Details window. You have to check the box, manually measure the references. Also, check that box. The auto remeasure references, because you're not going to do a good job with the joystick measuring your references, you want the CMM to automatically remeasure it. It updates the vectors of the measurements, so the second time it measurements, it'll probe perpendicular to the surface, which is what you want it to do. You can see our references are bolded in black, so it's going to have you measure the plane, then the 2 circles. It'll construct the line, and the program will run. Set report options is going to allow you to output, and underneath here you can have it output to a viewer, and then you can decide whether you want to save it or print it, or you could output it straight to a printer. I usually throw it to a viewer just to make sure that everything's okay before I commit to printing it or saving it. And at that point, you simply need to hit this button right here, and the program will ask you to manually reference the features, and then it should take off running. Dry run is set because I'm offline. This exercise is over.